Okay, hi, so welcome to this video where we're going to be speaking about particle theory. Now, what is particle theory? Particle theory is how we're going to be describing matter, right? It's a way of describing how matter is made up. Now, matter is just anything physical. So you're talking about any physical substance, that's what matter is. And we can describe that substance in terms of particles. Now, what is a particle? Well, a particle just means a very small thing, right? That's basically what a particle is. We can think of anything, right, any material, as being made up of these tiny little balls, right? So particles can be thought of as tiny balls which make up all physical substances. Okay, so in reality, if you think about something like water, right? So water or H2O. Okay, so you've got H2O. Now, if you take chemistry as well, which I'm sure you probably do, you should know that water is made up of two hydrogens and an oxygen, right? They're covalently bound together. Okay, they look actually like this. You've got an oxygen bound to two separate hydrogens like so, right? Now, one oxygen, two hydrogens covalently bound together. This is a water molecule. Now, if you contrast that with something, another substance, let's say propane. I've gone to the trouble of drawing this for you already. This is propane, right? This is one propane molecule. It's C3H8, right? And you've got 3 carbons and 8 hydrogens. That is a propane molecule, right? Now, my point here is when we're talking about substances, we're talking about particles. And those particles can be thought of as one single unit. So whether we're talking about water, which is made up of water molecules, like up here, or propane, which is made up of propane molecules down here. Okay, we can think of both of those just as small balls, right, which just float around. Okay, so a water molecule we can just draw as this circle. A propane molecule we could draw as the same circle. Right, each one of those are particles. So when you're talking about particle theory, right, what you're talking about are the individual building blocks, if you like, of your substance. For water or for any covalent simple molecular compound or substance or element, you're talking about molecules, right? If you're talking about an ionic substance, you're talking about individual ions, okay? If you're talking about a metal, you're talking about the individual metal ions that make up that metal. All of those are the particles, right? And we just draw them as a generic blob, basically. Now, when we're talking about particle theory, we can explain the properties of a substance by talking about the movement of these particles and the forces that act between the particles, right? Notice that we're not talking about the forces within the particles, right? If it's water, this force and this force, which are covalent bonds, are within the particle, right? We don't care about those. You're talking about forces between them, okay? Let me show you what I mean. Now, we don't care what substance this is. What I've got here are a few particles drawn, okay? Now, let's say that this substance is a solid, right? In solids, what you have are strong forces which hold your particles in place, right? So it might be you've got forces in between these particles. Doesn't matter what they are for now, right? But they're holding those particles in place. The particles are not actually able to move. Okay, so that's what we're going to say. In a solid, strong forces hold the particles in place. Yep, particles are unable to move. They instead vibrate around a fixed position. Okay, so if, for example, you were to heat this up, we'll get onto this in a second. You were to heat this substance up, these particles, let me just show you one like that. These particles would start vibrating more like this, right? But they can't move. It can't move over there because it's a solid. Those particles are fixed in place. That's basically how a solid is held together. Now, if it wasn't a solid, let's say when this substance turns into a liquid, right? Then things start to change. What happens when a substance turns into a liquid is that these particles are now able to slightly move around. Oh, that's my fault. Okay, this particle could now move maybe over here. This one can move, right, maybe over here. This one can move around, etc., etc. You get the point, right? There are still forces of attraction between them because this particle can't fly over here, right? That's not what happens in a liquid. They're still held together, okay? But the forces of attraction between them are weaker, okay? So the forces which hold the particles together are weaker, okay? Particles are now able to move, right? But importantly, the particles can move over each other, and they are moving slowly. Okay, also they're moving in random directions. Those particles are always just buzzing around, moving in random directions, but they're moving slowly and they're all close to each other. Okay, so random direction also. Okay, now finally, what happens is the liquid can be turned into a gas. Okay, so if we are talking about a gas, right, now this is where the forces between them are basically non-existent, right? We're not going to say that they're completely non-existent because there are still very weak forces between them, but they basically aren't there. These particles are allowed to randomly move wherever they want, okay, etc., etc. So, in a gas, forces between particles are extremely weak. Yeah, they're basically non-existent. Yeah, let me just move this over. So we got existent. Okay, particles are able to freely and randomly move to fill their container. Yep. And they are moving at far higher speeds. Alright, now one thing I want to quickly mention is that when we say the particles are moving at higher speeds, this basically means that they have more kinetic energy, right? So they have a higher amount of energy in their kinetic energy store. So they have a higher amount of energy. You can think of the particles as having more energy as they go from solid to liquid and then liquid to gas. Okay, so as particles are moving faster, they increase the amount of energy in the kinetic energy store. Okay, and therefore the highest amount of energy will be in your gas state and your lowest amount of energy is in the solid state because there's less kinetic energy in the solid particles as there is in the gas. All right, and finally I want to talk about pressure. Okay, so pressure is a property of liquids and gases, but really you only want to think about it in terms of gases. Okay, so if we have a gas, right, and you have your particles which are just buzzing around, they can go wherever they want, right, and they're inside some container, right, I'll draw the container in green, like this. Yeah, they're inside a container, and those particles are just buzzing around. What's happening is they're moving around and doing what they want, and at any given point, right, these particles are bumping into the walls of the container. Bang, bang. Right, this is buzzing around and then boom, hits the wall of the container, etc., etc. Okay, now when those particles hit the container, they're basically exerting a force. Okay, so hitting into, it's just like if you pushed into an object, right, you're exerting a force on the object. Exactly the same thing is happening here. Okay, so particles hitting the walls of the container are exerting a force onto the container. Okay, all right. Now the pressure, okay, the pressure is defined as, so pressure is the amount of force divided by the area. right? That's the equation, or that is the relationship between pressure, force, and area. Pressure is equal to force divided by area, okay? And let's assume your container isn't getting any bigger or smaller. That means that as you increase the amount of force which the particles are applying onto the container, you're increasing the pressure, okay? Now, how do you increase the force that the particles are hitting the container with? Well, what you do is you raise the temperature, okay? So increasing the temperature will cause an increase in pressure. Okay, why? Well, if you think about it, when you increase the temperature, these particles start moving faster. Okay, they're moving faster, and so then boom, boom. Yeah, when they hit the walls, they're hitting it with more force because they have a higher momentum. Okay, so increasing temperature increases the momentum of the particles. Particles, not particles. There we go. Which means they hit the container with a higher amount of force. Okay, another point, or the other point, is that if these are moving faster, then they're going to hit the wall more often. Okay, there's going to be more frequent collisions with the wall. Okay, which means the total amount of force exerted onto the walls of the container is higher as well. Okay, so as particles move faster, the collisions with the wall are more frequent, and so total force is increased. Okay, both of these things mean that the pressure increases as temperature increases. Okay, so as you increase the temperature, the particles are moving faster, so they hit the wall with more force, and also they're hitting it more often, which means that the total force is increased as well. Okay, therefore the pressure increases as the temperature increases for those reasons. Alright, now I'm going to stop there. I hope that made sense. That was a brief introduction into particle theory, right? You need to talk about solids, liquids, gases, and the fact that the particles are being held together, okay? Or the particles are not being held together in the cases of gases and are able to move fast and in random directions. Okay, you also need to talk about pressure in terms of particle theory as well. So I hope that did make sense. If anything still doesn't, then please feel free to put a comment in the box below or send me a direct email using the link. But as usual, please do like and subscribe because it really does help me out, and you will be notified whenever new videos become available, which is of course a good thing. But thanks for listening, and I'll see you in the next one.